Hello, in this screencast we're going to be talking about capture melt multiple, which is one way to compare the melt wide data tables to taller data tables. So in the last screencast we showed you capture melt single, which was useful for computing this kind of um, taller version of the iris data set, right? The usual iris data set has the sepal length, petal width, etc. variables all on different columns going from left to right. Now we have them as different rows going from top to bottom. All of the data is crammed into the centimeters column, and that's useful for making plots like this bar chart that we saw in the last screencast that shows you that well, here you can very clearly compare the length and the widths, and you can very clearly see that the length for all of the different petals and the sepals are much bigger than the widths. Well, this makes sense based on the definition of the length and the width. But so if we want to make another plot to investigate that, like perhaps we want to make a scatter plot of sepal versus petal, right? How would we do that, right? So in that case, what we would want to do is um, we would be wanting to create a ggplot, right, with some geom point. And that geom point, well, on the x-axis, we would want to put the sepal, maybe. And the y-axis, we maybe want to put the petal. And then, if the points are above the diagonal, then that means the petals are bigger. If they're below the diagonal, that means the petals are smaller than the sepals, right? So let's call that data equals iris parts. And so we could imagine doing that comparison for every unique value of dimension, right? So, we can imagine making a FastEgg grid and having different columns for the different values of the dimension, which length or width. So to make this plot, we need to create a data table called iris.parts with columns sepal, petal, and dim, right? So how are we going to do that, right? So the original iris data looks like this. So let's take a look at the original iris data, head iris. So here we have sepal length, sepal width, petal width, and species. So now what I'm going to do is I'm going to introduce a new function called nc capture melt multiple. And so this function is going to take as input, the first argument is always going to be the subject. Here is the data table with different columns that we want to match using a regular expression. And what we're going to do is we're going to just match, basically what we're going to do is create a regular expression for matching these guys. Here, I can create a regular expression that matches first anything, and then a dot, and then anything. Don't need the question mark there. And so here I'm going to get the names that I gave in the previous screencast were parts and dim. And that worked with capture melt single for creating that previous data table that we were looking at. But what happens if we use that with capture melt multiple? Well, it says pattern must define group named column. So what that means is that one of these two guys, you have to use the word column, and that's going to be a special group that's going to be used to create different columns in the output. So here, because what we want is we want a different column for each value of the flower part, we're going to change that part group to be a column group. So what it means is every unique value matched by that regular expression there is going to become a unique column name of the output. So let's see what happens when we run that. So when we run that, that becomes just exactly that data table that we're looking for. So here, now we have for every observation, every observation in the original data table has been kind of, reshaped to 2 rows in this output. And so now we have the petal and the sepal for every flower on um, on different rows, and then we have the dimension as sorry, we have the petal and sepal in different columns. We have the dimension as its own column, and then we can just immediately plug this thing into the data table. So let's call this, sorry, we can immediately plug this thing into the ggplot. So let's call this iris parts, and we're going to plug that into our ggplot. And so, you know, using the default scatterplot code that I wrote there, you can't really see the difference too easily, but let's add a geom AB line, slope equals 1, intercept equals 0, and let's add a chord equal. And so let's make sure we didn't have a typo here. I think we have a typo, yeah. So what happened there? Yeah, that's okay. Maybe that's the problem? Unexpected, comma, and x equals sepal? Is that right? Well, I guess I was just pressing return in the wrong place. That's funny. That's ggplots for you. Anyway, so there was no syntax problem. Now I have added the geom AB line and the chord equal, and so we can see now that indeed the petals are smaller than the sepals, right? So here we see that, for example, you know, we have petal of size 4 centimeters for a sepal size 6 centimeters, length 6 centimeters. You know, same thing for the width, right? Here there's a petal uh, that's about 2 centimeters, and it's smaller than the sepal, which is a size about 4 centimeters. So that's what we can do to answer our question. So we introduced this function NC capture melt multiple. Function is pretty similar to the capture melt single, but it's got this special group that you have to specify called column. And so the column, it's going to, you know, in this case, we matched the first part, and that gave us this data table iris parts with different columns for petal and sepal. So if, you know, we want to make the converse of this plot, you know, what if we wanted to plot length versus width and have petal and sepal on different different panels? So let's try that. So to do that, here I'm just going to make a copy of this code, and here I'm going to call this iris dims now. So now if we instead call this part, and now we call this column, what do you think happens, right? So iris dims now is going to be this new data table where you have columns for length and width, which are the unique values which were matched by this column group. And it's going to have a column for part here. You know, this is all the different values that were matched by this group. And it's going to have all of the rest of the columns that were not matched by any of the regex. That's the species column in this case. And so here in the ggplot code, what we can do is we can change dim to part. We can change x equals length, y equals width, data equals iris dims. So we can make the same plot and see what it looks like. And so you can see here that, you know, the width is less than the length for all of the petals and all of the sepals. So that makes sense. Okay, so just to summarize, you know, what we saw in this screencast was capture meld multiple. So this is a way of reshaping data based on regular expressions. The first input argument is the data table to reshape, and the rest of the arguments are going to match the columns, the column names of that data table. So here, there has to be at least one of these groups has to be named column, and that group is kind of like a special group that's going to create a new column for every in the output for every unique value that was matched in that pattern. So here, here we used it in the first case, here we use it in the second case. You can use it anywhere you want in your pattern, but it must be used exactly once in the definition of the pattern that you use with capture melt multiple. Thanks for listening.